Hey students, welcome to IMST online classes. Now, in our last video, we studied about the physical properties of metals. Okay. Now, we are going to study about physical properties of non-metals. And before moving on to physical properties of non-metals, we should know what do you mean by non-metal. I hope you remember what is the definition for metals, right? Metals are generally substances which are electropositive in nature. Similarly, we can say non-metals are substances which are electronegative in nature. Electronegative means that is they have a tendency to, okay, there's a mistake, okay, not to lose but rather to gain electrons. Okay, they have a tendency to gain electrons. Now, try to recall that, as I've said, that everything in this world is made up of atoms and molecules. Atom is the smallest unit, and you can consider that atom is a mixture of positive and negative charges. Okay, it contains positive charge and negative charge in equal amounts. Okay, so in case of metals, they are the substances which want to release the negative charges, so they become electropositive. For non-metals, they want to accept one negative charges inside. So since this one is equal, one negative charge inside makes the whole system negative, so they are called as electronegative. So substances which are electronegative in nature, that is, they can gain electron, they can receive electron, are said to be non-metals. Okay, for example, we can take this oxygen, nitrogen, carbon, and many such compounds are there. Okay, so understood what is non-metals? Now let's move on to our topic, that is physical properties of non-metals. Okay, now let's study about the physical properties of non-metals. If you remember, as I've said earlier, physical property means generally the property which we can see directly or which we can feel. That is physical property, like appearance, color, then shining, hardness. This is called as physical properties. Now, the first is physical state, means in which condition these non-metals are found. Generally, there are three states of matter, most commonly solid, liquid, and gas. And as we have studied, in case of metals, they are mostly found in solid state except for one, that is mercury, which was in liquid state. But in case of non-metals, they occur in all the three forms. They can be found in form of solids, in form of liquid, and also in form of gas. Solids, like example, sulfur, phosphorus, they are used as fertilizers. Okay. Then liquid, bromine is a type of non-metal which is used, which is liquid. Then in gases, there are a lot of non-metals which are actually gases, like oxygen, nitrogen, hydrogen. These are the examples of non-metals which are in gaseous form. So at room temperature and under normal pressure, non-metals can be found in all the three forms. Okay. Now, moving on to the next physical property is appearance. If you remember, metals, they had a specific shine that is called as metallic luster. But in case of non-metals, they are generally dull. If you recall, if you might have seen the coal, okay, it's a pure form of carbon. It is quite black, dark, right? It doesn't have a shiny appearance, right? But similarly, most of the non-metals, they have dull appearance. That is, they are not lustrous, okay, except for iodine. Iodine is a type of non-metal which is generally very shiny. And also, if you include diamond. Diamond is another type of carbon, it is entirely made up of carbon, and it is also one of the shiniest objects known to us. Okay. Now, malleability and ductility. I hope you remember what was malleability and ductility. Malleability, the ability of a substance to be converted or beaten into thin sheets. Okay, that was called malleability. It means if you can change a substance into sheets. Okay. And ductility, the ability of a substance to be converted into thin wires. We know metals were both malleable and ductile. Metallic sheets are used in different places and also metallic wires. But in case of non-metals, if you see, neither they are malleable nor ductile. That is, they can be converted into thin sheets or they can also be converted into wires. Mostly if you see, that's why wires are generally made of metals. Some might argue that the plastic coverings are used, plastic wires are there. Plastic is a compound which is a mixture of various things. Okay, a single non-metal cannot be converted into wires. Rather, non-metals are brittle. Brittle in the sense that is, if you put pressure on them, if you hammer them, they will break into small pieces. Okay, so they can be converted into sheets or wires. Understood? Now, if you want to note it down, you can pause the video and you can note it. Okay. Moving on to the next one. The next physical property is conductivity. Conductivity means the ability to allow something to pass through itself. Recall, in case of metals, they were good conductors of heat and electricity. But for non-metals, they don't allow heat and electricity to pass through themselves. Or we can say they are poor conductors of heat and electricity. So that's why they are used for as insulators. Okay, for the handles of utensils or covering in electric wires or electrical devices, because they don't allow electricity to pass through them. It is also advantageous for them. All generally non-metals are poor conductors of heat and electricity except graphite. Graphite is rather a good conductor of heat and electricity. Now, the next physical property is density. Density, the amount of substance present per unit volume. Okay. So for non-metals, generally they have low densities. Okay. That's why they are quite soft, except for one non-metal, that is diamond. Diamond is one of the hardest natural substance known to mankind. So it's a non-metal, but still it has high density and it is quite hard. Okay. Next physical property is melting and boiling point. Now, what is melting and boiling? Generally, it is a temperature at which the substance converts from solid into liquid or liquid into gas. Solid to liquid, melting point. Liquid to gas, boiling point. Recall, for water, the melting point is 0 degrees Celsius. That is for ice, 0 degree Celsius. And for water, the boiling point is 100 degree Celsius. But in case of metals, it is quite more. Okay, rather 200, 400, 500 or ever more degrees Celsius is needed for to boil them or to melt them. Okay, but in case of non-metals, they have low melting and boiling points. They can be easily melted or they can easily be boiled. Last but not the least, the physical property is sonority. Sonority means the ability of a substance to produce sound when struck. But in case of non-metals, they are non-sonorous. That means they do not produce sound when hammered. Rather, but they are brittle, right? They will break easily. So non-metals are non-sonorous. So, okay, understood? What are the physical properties of non-metals? Right? Let me make you a small recall. First was nature of state. That non-metals occur in all the three forms. That is solid, liquid, and gas. Then they are neither non-metals, neither they are malleable nor they are ductile. That is, they cannot be converted into thin sheets or wires. Rather, they are brittle, right? That is, they break when hammered. Then conductivity. Conductivity, non-metals are poor conductors of heat and electricity. Then non-metals have low densities. They are quite soft except for a diamond. Then non-metals do not produce sound. They are non-sonorous. Then non-metals have low melting and boiling points. So these are the physical properties of non-metals. Okay, try to understand each of them and try to remember.